In order to understand how organic molecules are formed, we will first need to discuss how our atoms organize in the molecules. And so we'll talk about atomic structure a little. So each atom is composed of a nucleus and its electrons. And each nucleus in turn contains protons, which have positive charge, and neutrons, which don't have any charge. Electrons, on the other hand, have negative charge. In terms of masses, mass of a proton is roughly equal to the mass of neutron, but it's much bigger than the mass of an electron. So about 1800 times heavier than an electron, which practically means that all of the mass of an atom is concentrated in its nucleus, and all of its positive charge. All of its negative charge is in electron cloud. A traditional, although nowadays certainly wrong picture of an atom would look somewhat like this, where we would have little spheres for protons and neutrons, and then little electrons flying around in these orbitals. But that is nowadays most certainly incorrect, because it's pretty well understood that electrons are not only discrete particles, but also exist in the form of waves as well. Now, a number of protons in nucleus is equal to the number of electrons to satisfy charge neutrality. But that doesn't tell us anything about the number of neutrons in a nucleus. And indeed, the number of neutrons can vary in a nucleus with a given number of protons. For example, carbon has 6 protons and 6 electrons, and that is what makes it carbon. But for that given number of protons, there are 3 variants of carbon which all exist. There's carbon-12, which has 6 protons and 6 neutrons. Carbon-13, which has 6 protons and 7 neutrons. And carbon-14, which has 6 protons and 8 neutrons. And carbon-14, by the way, is unstable because it's radioactive. And although all of these variations are really carbon, they differ in a number of neutrons, and so their nuclear properties are different, while their electronic properties are identical. These different forms of a given element are called isomers, and are called isotopes, and are actually very common in physics and chemistry. In fact, most of the elements are not what we call monoisotopic, but they have several different isotopes. Typically one prevails, whereas the other ones are just minor components. In case of carbon, carbon-12 is 98.8%, carbon-13 is 1.1%, and carbon-14 exists in traces. We will not be too concerned with the question of isotopes until we start studying nuclear magnetic resonance later in the course, because that is one of the rare topics of this course where nuclear properties are relevant. In most of the time, chemists are concerned with electrons. And so since isotopes have same electronic properties for all practical purposes for chemistry, they're identical. On the other hand, physicists study nuclei, and so this is a topic of great interest to them.